Welcome to this video from In 28 Minutes. Thanks for helping us provide awesome learning experiences to more than 300,000 learners across multiple platforms, Udemy, Safari, and Pact. Let's welcome our lead instructor, Rangarao Karanam. The first of a series of 3 videos about microservices, we would start introducing you to the concept of microservices. In this video, we will learn what is a microservice, what are the advantages of going for a microservice architecture, what are the challenges in developing microservices, and we would introduce to an awesome framework called Spring Cloud. It's not actually a framework, it's actually a set of projects. So we'll talk about Spring Cloud and how it provides solutions to most of the challenges of microservices. After that, we would look at what is the difference between a microservice and service-oriented architecture. If you look at the last 2 decades, we use service-oriented architecture a lot. And now there is new thing called microservices. What are the differences between these two? We will discuss that. And after that, we would look at how you can take the first steps from a monolith architecture to a microservices architecture. There are a wide range of topics that we would be covering as part of this long video, and I am excited to bring this to you. I'll see you in the first step. We would be talking about what is a microservice. In the previous section, we talked about the fuzzy world of RESTful web services. With microservices, things get even more fuzzier. There is no one accepted definition of a microservice. So, definitions vary from a smaller one like this, which says it's a small autonomous services that work together, to very long definitions. This is the definition which was given by Martin Fowler and James Lewis. This is like a 10-line definition on its own. It says it's a style to develop a single application as a suite of small services, each running its own process, communicating with very lightweight mechanisms, things like HTTP. And these services are built around business capabilities, independently deployable by automated deployment, and there is a set of centralized management for these services. These services might be written using different programming languages and maybe using variety of data storage technologies. The definitions I'm showing you here are just a couple from a lot of other definitions which are present for microservices. So I don't really want to get into the world of what is a microservice and what is not a microservice and how to define it and all that kind of stuff. Let's get started with a few things which I really consider are important for a microservice. For me, microservices are basically services which are exposed by REST. In addition to that, you have small deployable units with very well thought out boundaries. Small, well chosen deployable units, and these should be cloud enabled. So for me, the important parts are REST, having small deployable units which can be cloud enabled. Now, what do I mean by this? What do I mean by cloud enabled? How does it look? For me, when you build microservices, this is how it would look. Instead of building one big monolith, you'd be building a set of smaller microservices. I'm showing 5 in the picture. It might be 10, 15, 20, 100 or 1000. So it's a set of microservices with well defined boundaries which are interacting with each other, and these are cloud enabled. That means I would be able to have multiple instances for each of these microservices. For example, we are looking at the diagram of a production deployment for a set of microservices. You can see that at this moment there are 2 instances of microservice 1, 4 instances of microservice 2, and 1 instance of microservice 3. By cloud enabled, I mean that if there is more load on microservice 3, I should be able to easily bring up another instance of microservice 3. This should not involve a lot of configuration. I should be able to bring up an instance of Microservice 3 or take down an instance of Microservice 2 without having huge problems. That is what I mean by cloud enabled. So as far as this course is concerned, we already looked at RESTful web services. What we'll look at in the subsequent sections in this course is how to cloud enable them, how to set up an architecture such that it would be able to dynamically adjust and be able to bring new instances up and take the older instances down. In this step, we kind of gave you a high level 1000 feet picture of what we think about microservices. In the next step, we'll go one level deeper and look at the challenges that are associated with cloud enabling your RESTful web services. Welcome back. In this video, we would be discussing about some of the advantages of microservice architectures. The most important advantage of the microservice architecture is that it enables you to adapt new technology and processes very easily. When we build applications as a combination of microservices which can communicate with each other using simple messages, each of these microservices can be built in different technologies. In typical monolith applications, we would not have that flexibility. For example, microservice 1 might be Java, microservice 2 might be Node.js, microservice 3 might be written in Kotlin, and tomorrow there might be a language XYZ which is really doing well and which provides a lot of benefits to you, and you can easily create a microservice in that specific language. And also for the new microservices that we create, we can bring in new processes as well. The other important advantage of microservices is dynamic scaling. Consider an online shopping application like Amazon. They don't really have the same amount of load or same amount of traffic or same amount of users throughout the year. Especially during the holiday season, the load on the applications will be a lot. And during the rest of the year, there might not be so much load. During the Black Friday, there might be a huge amount of load. If your microservices are cloud enabled, they can scale dynamically and you can procure hardware and release it dynamically as well. So you can scale up your applications and scale them down based on the load. Because you are developing smaller components, it's much easier to release microservices compared to monolith applications. This means that you can bring new features faster to market. And that's a big advantage to have in the modern world. In this video, we discussed about 3 of the most important advantages of microservices: adoption of new technology and processes, dynamic scaling, and faster release cycles. Until the next video, bye-bye. In 28 minutes. In this video, let's discuss about the different challenges with building your microservices. We'll start with the problem number 1, which is bounded context. What do I mean? Earlier, we said instead of one big monolith application, we would be building about 5 small microservices, or 10, or 20, or 100. How do you identify the boundary for each of these microservices? How do you identify what to do in each of these microservices? How do you decide what you should do and what you should not do? The thing is, for new applications, this is especially much more difficult because probably you don't really have the business knowledge to be able to establish the right boundaries between these microservices. What I found in my experience is deciding the boundaries of microservices is an evolutionary process. It's not something you would get it right the first time. It's something which you need to play around with, try and follow domain-driven design, try to identify the right boundaries for the microservices based on the knowledge you have at that point in time. The important thing to understand is as you keep gaining knowledge, you should put that knowledge back into the microservices, into deciding what is the right boundaries for these microservices. The next important challenge for microservices is configuration management. We said we would have 5 or 50 microservices. These microservices have multiple instances in each environment, and there are multiple environments. So let's say there are 10 microservices with 5 environments and let's say 50 instances. So we are talking about basically tons of configuration, and that's a lot of work for the operation team to maintain. Third important challenge is the dynamic scale up and scale down. Establishing the technology to be able to do that. The loads on different microservices will be different at different instances of time, and at particular instance I might need 2 instances of microservice 2, but later at a different point in time I might be needing 10 instances of this. So I should be able to bring the new instances of microservices up and bring down older instances of microservices when they are not really needed. All this with dynamic load balancing, because when there is one instance of microservice 1 and there are 4 instances of microservice 2, then I would want to distribute the load between all the instances of microservice 2. And if there are 4 instances of microservice 2 coming up, then I would want to ensure that all the new ones are also being used to the fullest extent. So we need the ability to dynamically bring in new instances and also to distribute the load among the new instances. The fourth and one of the most important challenges is visibility. If I say the functionality is now distributed among 10 microservices and there is a bug, how do you identify where the bug is? You need to have a centralized log where I can go and find out what happened for a specific request, which microservice caused the problem. Not just that, we also need monitoring around these microservices. Because we have hundreds of microservices, we need to be able to identify the microservices which are down. We would want to be able to automatically identify servers where there is not enough disk space. All these kind of things need to be automated. So we need great visibility into what's happening with these microservices. And the last but not the least important of them is the fact that if it's not well designed, microservices architectures can be like pack of cards. What do I mean? It's basically that in microservices architectures you have one microservice calling another, another calling another. So there would be certain microservices which would be the fundamental for the whole thing, and if that microservice goes down, then the entire application might go down. So it's like a pack of cards. You're building one over the top of the other and so on and so on, and therefore they can collapse very easily. And therefore it's very important for you to have fault tolerance in your microservices. In this video, we looked at the 5 important challenges related to microservices. We started with bounded context, identifying what is the right context for your microservice, what is the right boundary for your microservice. We talked about the problem of configuration management. Hundreds of microservices and a lot of environments, there is tons of configuration that you would want to manage. How do we simplify that? We would want to be able to dynamically scale up and scale down and dynamically distribute load among the active instances. How do we do that? We want to have great visibility into what's happening behind the scenes with each of these microservices. A simple request might involve 10 microservices. How do I determine which microservice was the cause for a defect? How do I know if all my microservices are up and running? And how do I prevent one microservice being down, taking down the entire application? How do I build fault tolerance into my microservices? Until the next step, bye-bye. Welcome back. In the previous video, we discussed about the challenges with microservice architectures. In this video, we would introduce you to Spring Cloud
and we would talk about various components under the umbrella of Spring Cloud which help us to provide solutions to the challenges we discussed. Let's get started. If you go to the home page of Spring Cloud, which is cloud.spring.io, it says Spring Cloud provides tools to quickly build some of the common patterns in distributed systems. To the typical problems which are present for distributed systems in the cloud, Spring Cloud provides a range of solutions. The most important thing that you need to understand is Spring Cloud is not really one project as such. There are a wide variety of projects under the umbrella of Spring Cloud. On the Spring Cloud homepage, if you scroll down further, you'd be able to see a huge variety of projects which are related to Spring Cloud. One of the important projects in Spring Cloud is Spring Cloud Netflix. Netflix was one of the organizations which started playing around with the microservices architecture very early. There are a wide range of components that Netflix has open sourced under the project Spring Cloud Netflix. Later in this course, we would be talking about a couple of them as well: Eureka, Hystrix, and Zool. Other than Spring Cloud Netflix, there are a wide range of projects under the umbrella of Spring Cloud. Some of them are Spring Cloud Config, which is to provide a centralized configuration management. Spring Cloud Bus, this enables the microservices and the infrastructure components, things like config server, things like API gateway, to talk to each other. In this course, we will be using the Finchley M2 release of Spring Cloud. Now, let's take a quick look at the challenges which we discussed earlier and the projects in Spring Cloud that provide solutions to those challenges. One of the challenges we talked about earlier was configuration management. We talked about the fact that there would be multiple microservices, multiple environments for each of these microservices, and multiple instances in many of those environments. This would mean that there is a lot of configuration for these microservices that the operations team needs to manage. Spring Cloud Config Server provides an approach where you can store all the configuration for all the different environments of all the microservices in a Git repository. So you can store all the configuration for different environments of different microservices in just one place, in a centralized location. And Spring Cloud Config Server can be used to expose that configuration to all the microservices. This helps us to keep the configuration in one place, and that makes it very easy to maintain the configuration for all microservices. The next challenge we talked about was the dynamic scale up and scale down. In the example you are looking at, there is a microservice called Currency Calculation Service which is talking to the Currency Exchange Service. As you can see in the diagram, there are multiple instances of the Currency Exchange Service, and it's possible that at any point in time new instances can be added in or removed out, and we would want the Currency Calculation Service to be able to distribute the load between all the instances of the Currency Exchange Service. We would want to be able to dynamically check what are the available instances of the Currency Exchange Service and make sure that the load is distributed among all of them. The solution which we would be discussing in this course would be using a naming server, which is Eureka. So all the instances of all microservices would register with the naming server. So the naming server has two important features. One is service registration. So all microservices can register with the microservice. The second one is service discovery. So in this example, the Currency Calculation Service can ask the Eureka naming server, Hey, naming server, give me the current instances of currency exchange service, and the naming service would provide those URLs to the currency calculation service. This helps to establish dynamic relationship between the currency calculation service and the instances of the currency exchange service. We will use ribbon for client side load balancing. That means the currency calculation service will host ribbon, and it would make sure that the load is evenly distributed among the existing instances that it gets from the naming server. We'll also use feign in the currency calculation service as a mechanism to write simple RESTful clients. The solutions for visibility and monitoring are A. Zipkin distributed tracing server. We would use Spring Cloud Sleuth to assign a ID to a request across multiple components, and we would use Zipkin distributed tracing to trace a request across multiple components. One of the important things about microservices is these microservices have a lot of common features. For example, logging, security, analytics, and things like that. You don't want to implement all these common features in every microservice. API gateways provide great solutions to this kind of challenges. We will use a Netflix Zool API gateway in this course. We will also implement fault tolerance using Hystrix. If a service is down, Hystrix helps us to configure a default response. In this video, we took a quick look at the various components which are present in Spring Cloud to provide solutions to the challenges which we discussed earlier. The idea behind this video is to help you get a high level big picture. If you have a few questions about what each component does, that's okay. We'll discuss about each of these components in detail as we take them one by one in the next steps. Until the next video, bye-bye. In 28 Saranam. Welcome back. One of the frequent questions that's asked is how is microservices architectures different from service-oriented architectures? Right? It's a great question because whenever we talk about service-oriented architectures, what are we talking about? Services. Alright? That's exactly what we talk about when we talk about microservices too. We talk about microservices. So we say small services. However, whenever we talk about service-oriented architecture, it's also creating independent services, and independent services are small, right? So that's a great question to ask when you say what is the difference between a microservices architecture and a SOA architecture, all right? So let's look at the key differences right now. Whenever we talk about microservices architecture, we not only focus on small services, but we also focus on independently deployable components. We would want to be able to release microservice 1 without changing any of the other stuff. Should be able to take it to production very, very quickly. So that's one factor where microservices is very different from SOA. In SOA, the focus is on creating independent services, but not on being able to deploy them independently. So you would have large applications which are built around services, but if you have to take them live, then you have to take the entire application live. So that's one key difference. With microservices, you have smaller deployable components. One of the other important things with the SOA architecture was after a little bit of time, SOA architecture resulted in having large enterprise buses. Whenever you needed to implement something, you needed to make a change in your application, as well as you need to make a change on the enterprise bus. The enterprise service bus became one of the central spokes where a lot of business logic went into it. Over a period of time, these attracted up all the business logic of the applications, and they became really, really difficult to maintain. In the microservices architectures, the focus is on avoiding something like this. That's why we use the terminology thin pipes. Basically, the infrastructure that you'd use to connect applications should be as thin as possible, should not have any business logic at all. all the business logic should be inside the real applications and not inside the connecting pipe. That's another key difference between microservices and SOA architectures. Now, let's look at a few more differences. As we discussed earlier, big vendors hijacked SOA in a way to create products like enterprise service bus. Like there are a huge number of enterprise service buses, and a lot of logic went into the enterprise service buses. The other thing is SOA was really tied to XML, right? So at that point, SOAP was very famous. So SOA was really tied to the XML, to the formalities around it, to the complexities around it. So also focused on having centralized governance. So you had kind of an architecture team which governed what went into the enterprise service bus, what it can do, what it cannot do, what can be done in a specific application, and so on and so forth. And microservices architecture typically focuses on decentralized governance. It's a governance system where you have a team of people, like including the developers, meeting and making decisions based on inputs from the development team as well. As we discussed earlier, SOA did not really focus on independent deployability of the applications. It was just focused on building independent services, but not worried about the deployability of them. We also talked about the fact that SOA resulted in complex ESBs, which became the central point for attracting business logic. And the pipe, I mean, ESB is basically like a pipe, right? So the pipe became very, very smart. And with microservices, we try and have dumb pipes, but smart endpoints. Let's look at a sample example. Let's say there's a sales app where you're requesting a customer to fill in what are the stuffs he would want. He might want a saving account, he might want a debit card, a credit card, and things like that, right? So in a single order, you can have one or more of these to be created. So in a SOA architecture, the way we would implement it is the sales app would put the order and the ESB would have the logic. It would have all the logic to decide how to create a savings account, how to create a debit card and the credit card as well. So it will look at the order, try and look at the request which is coming in and create appropriate requests to the savings account and the debit card and the credit card systems. However, in the microservices architectures, the way I would implement that is by creating an event. So the sales app would create an event called a new order event. And each of these systems would be listening on to all the events. And each of these systems would look at the event and see if it's interesting to it. And if it's interesting to it, it would pick it up and process it. So the logic is moving away from the ESB. It's no longer inside the centralized hub. It's no longer inside the pipe. Each of these microservices would be intelligent to understand if they need to process the order or not. So the architecture is more a event driven architecture. In 20 Hi, in 28 minutes. Welcome to this video where we'll be talking about how you can take the first steps from a monolith to a microservice. So you have an application with monolithic architecture or large application, and you'd want to start moving towards a microservices architecture. We'll discuss about the basics of a monolith architecture, the basics of microservices architecture, and we will give you a few ideas on what you can do to take your first steps. Now, if you have any experience with working with monolith applications, then you would know that these projects are released every few months. I mean, you're not talking about releasing every week, every day. Like organizations like Facebook, Twitter, they release multiple times every day. And in comparison, these monolithic applications are released to production once every few months. These monolith applications have large amount of features and functionality. They are huge. I've worked with monolith applications which have more than 50 team members working for one application. I'm just talking about the development team. And you'd see typically in monolith applications that debugging problems is a big challenge. Changing anything in how things are done, like whether you are talking about technology, whether you're talking about bringing in new processes, is next to impossible. So, what is a monolith application? Typically, the way I would think about it is any application which is very difficult to take to production, for which you have to do a lot of effort before you take it to production. That's a monolith application for me. So typically when we are talking about a monolith application, it looks like this. You have a large database and you have a large application which is talking to it. What does microservices architecture brings in? The microservices architecture says instead of building large applications, try and build a number of smaller microservices. So instead of thinking of this kind of an architecture, start thinking about this kind of an architecture. Instead of building one movie application which provides the entire stuff behind a specific website, build a number of services. So you have a movie service, you have a customer service, you have a review service, a booking service, and a fare calculation service. And as you can see in here, the databases are also separated out. So you have smaller databases and you achieve functionality through the interaction between these microservices. So these microservices talk to each other and they provide the functionality for you. While microservices architecture looks very easy from a high level, implementing this kind of an architecture is really complex. There are a lot of important decisions to make. What are the boundaries of each of these microservices? So you have one large application, so it's easy. You put every functionality into that. But when you break it up, how do you break it up? What should go into an individual microservice? What should go into the database which is related to that specific microservice? How do you have these microservices communicate with each other? So there are a lot of challenges which you have to face when it comes to microservices architecture. Let's look at a few of them. One of the important ones is when we are talking about building tens, 15s of microservices, you cannot spend a month setting up the frameworks, right? So you have to be really quick. So you need to be able to create microservices on the fly. The second important thing is if I'm having 15, 20 microservices, I would need to take this live, right? So I would want to take all these microservices live, and it's a lot of effort, and that's why you'd want to automate everything. You'd want to automate your build, you'd want to automate your deployment, you need to have automated monitoring to find out if something is down. So there's a lot of automation that is required when you move to a microservices architecture. As we discussed earlier, bounded context is a very important challenge. How do you decide what is the boundary of each of these microservices? What does a microservice do? How do you decide that? In my experience, what I've found was deciding this at the first go is very difficult. This is something which evolves. So you need to keep an eye on it. So at the start, you think, okay, these are the microservices I would need. This is the responsibility for each of these microservices. But over a period of time, that would evolve as you understand more about your business and your specific needs. Now, configuration management is also a challenge. Managing configuration for one application is difficult, right? So the configuration changes from environment to environment. Configuration is typically which database you talk to, which external service you need. There might be a lot of other configuration which varies between each of your environments. So the same application will have different configurations in different environments. And now we are thinking about hundreds of microservices, and each of these microservices has different configuration. So managing the configuration for all of them is going to be a challenge. The other things are, the reason why you go to a microservices architecture is to be able to do auto scaling. When you have more load, you would want to be able to have more instances. When you have less load, you would want to have less number of instances. That's called auto scale up or dynamic scale up and scale down. And you need to have all the infrastructure in place to be able to use that facility. So what we are looking at right now are some of the important challenges with respect to microservices architectures. You might be wondering, we talked about monolith applications and we directly jumped into challenges with microservices architectures. Why did we do that? Why didn't we talk about the advantages of microservices and then jump into the challenges of microservices? The reason is because you're looking to migrate from monolith application to a microservices application architecture. And that's not easy. I just wanted to highlight the important challenges which are really involved in taking a monolith architecture and making it a microservices architecture. The important thing that you need to realize is this is not something which you can do in a few months. You cannot say I have a monolith application and I would stop working on it and I'll make it a microservices architecture in a few months. That's not how it's going to work. Getting a microservices architecture right is years of work. It's a number of years of work. So it's kind of a journey. So it's not a switch, but it's kind of a journey. So you would have the monolith application and a part of it in microservices architecture running in parallel for a long time. So it's not a simple journey. It would be involving a lot of complexities, especially because designing a monolith architecture is very different from designing a microservices architecture. The thought processes are very, very different. So now you would want to move from monolith to microservices. What should you start doing? One of the most important decisions that you need to make when you are moving from a monolith to a microservices architecture is why. Why do you want to move to microservices architectures? Do you want to adapt new technology faster? Is that the reason why you are moving to microservices? Or you'd want faster release cycles? Is that why you are moving to microservices? Or you'd want to auto scale? You'd want to move to the cloud and get infrastructure whenever you need it. Your load on the applications is varying, so you want to make sure you'd want to auto scale with load. Which of these is the important reason why you would want to switch to a microservices architecture? You need to be very, very clear about it. The approach you would use would differ based on which of these factors is the most important thing for you. Let's say you would want to start adapting new technology. In that kind of situation, what you can start doing is you can start with designing microservices around the next important features that you would start building. So when we are having a monolith application, there would be a lot of requests to change stuff, add features. So whenever you would want to add new technology, you would want to try new technology, the best place to try that would be in the new features that you are creating. So the approach in that situation would be to start off with trying these new technologies and implementing microservices architectures for the new features. How do you design the database? How do you make sure that the data is shared between these two things, like the old monolith application as well as the new things that you are creating in the microservices architecture? So you need to make those decisions, but the important thing is you can start trying out stuff with the new features you are developing. The second reason might be faster releaser. Cut. The second reason might be that you want faster release cycles. Your business is not happy with the pace at which we are releasing stuff to production. If that's the case, the most important thing that you need to identify is what are the parts of the application where there are frequent changes. You need to identify why are we having a lot of releases, which parts of the application are very, very dynamic. Once you identify that, then you can design a solution where you can take out the moving parts and create microservices around them. That would help us make sure that whenever there's a change, you just need to release that specific microservice. The last reason might be to scale with the cloud. If that's the reason, then you need to start thinking about what is involved in taking your monolith application and putting in the cloud. So start doing research, start doing POCs around trying to put your application in the cloud. What are its dependencies? Which of the dependencies are important to break? What are the problems that you are having when you actually try and make your application cloud native? So the approach that you would take to the journey from microservices to monoliths is a little different depending on what your aim is. It's not going to be the same journey for everybody. However, the most important thing is whatever microservices that you create, you need to make sure that you have all these things in place. The most important thing is having a lot of automation around all your processes. Two is having the facility for auto scaling. The third thing is to have great visibility, right? You need to understand what's happening behind these microservices. In this quick video, we looked at how you can move from a monolith architecture to a microservices architecture. We said it's not going to be a I hope you had an interesting time watching this video on microservice. The idea behind this video was to give you a theoretical overview around microservices, but if you are interested, then you can check out our course on microservices. You can take the link to the GitHub repository and search for microservice, and you should see an awesome course helping you build a microservice with Spring Boot and Spring Cloud. In 28 Minutes is providing awesome learning experiences to 300,000 learners across platforms like Udemy, Safari Online, and Pact. We have clocked million hours of learning in the last few months. The question is, what do you want to learn next? We are building solutions to help programmers at all levels. You can learn programming with our awesome courses on Java, Python, and JavaScript. You can learn full stack development with REST APIs and microservices with a wide range of frameworks like Spring Boot, Node.js, React, Angular, and Spring Cloud. We have 200 plus videos to help you start your journey from a programmer to a software architect. We have videos to help you learn frameworks, industry trends, including things like microservices, learn the best practices in architecture, design, and code quality. Thanks for watching. Keep learning in 28 minutes.